So for this example that we have over here, it says simplify the following. And what we have is the group 2 times x to the 0th power times y, all to the 3rd power, times the group 4 times x times y to the 5th power over x cubed y, all to the -2 power. And we want to simplify this as much as we can using properties of exponents. What we mean by that is getting one variable group. There's no reason to have x's over here and x's over here and x's over here. When we simplify it, we'll have one group of x's. Same goes for the y's, and same goes for any coefficients that we have, like the 2 and the 4. Those can ultimately be simplified at some point, as we'll see going along. We also want to make sure that we don't have any negative powers. Again, negative exponents are just typically not considered to be simplified, depending on what we're dealing with in mathematics. And so let's dive in. The first thing that I see, my first preferred thing, is always the 0th property, because the 0th property is the easiest thing to get rid of. Remember, again, there's no order of importance. I decided to start by tackling the 0th property. Maybe you would have decided to start by tackling this 3 outside, or this negative here, or something like that. But anyways, this x to the 0th power turns simply into the number 1. So let's go and rewrite all of this. Only changing one thing at a time, we're going to change that to the number 1. So first things first, I still have my parenthesis, and I have my 2. Right after I have my 2, I know that this turned into, instead of 2 times x to the 0th power, it turned into a 2 times 1. And I have my y here, and I have my 3rd power. So I just rewrote the first group, changing the one thing that we changed. The second group we haven't changed at all, and I always like to say if it doesn't change, it stays the same. So I'm just going to rewrite this one exactly how I see it. We haven't simplified anything quite yet, but we will at some point. Nice, okay. And so what do we see? Over here, I have 2 times 1 times y, all inside of a group to the 3rd power. Well, 2 times 1 times y, that's just 2y. And so inside of this first group that I have to the 3rd power, I have 2y to the 3rd power. I'm going to have to use one of these properties of exponents to simplify that, but I also still have times this here. So I'm going to go and rewrite it. We're changing one thing at a time, which may take longer than necessary, but at least it shows that we understand every single part of what we're doing. As we get more comfortable, we can start to trust ourselves more to skip steps and such. Now I'm going to approach this part. I see that I have 2 things inside of some parenthesis group being put to some power, and I wonder, which property can I use to simplify that? I think that looks most similar to property 6 here, where I have an x multiplied times a y inside of a parenthesis group, all to the nth power, and we distribute, in a way, the power to whatever the first thing in the group is times the second thing in the group to the same power. And so I'm going to apply that here, where I'm going to say 2y to the 3rd power is really just 2 to the 3rd power times y to the 3rd power, because in a way I distributed the power. Some people like to call it shower the power, because the shower sprinkles over everything inside of the group, and now everything in the group gets the power. And I still have not changed this, so I'm going to rewrite it. Could I have changed some little things by now? Maybe, but we haven't yet, and that's okay. One thing at a time to make sure that there's no possible way of making a mistake. As I continue, what do I notice? Well, I see I have 2 to the 3rd power, which of course is just 8 according to my calculator. I have y to the 3rd power, which is just y to the 3rd power. And so I can rewrite this part here as 8y to the 3rd power. And the second part, well, it hasn't changed, so it stays the same, but I'm ready to change it. Let's dive in. First things first, I know I want to start inside of the parenthesis group. So I'm going to start inside of here. I'm going to ignore this -2 outside for right now. And that's not necessarily how I had to start it, but this is how I prefer to start it. Starting it like that, I want to simplify the inside that we have here. And so simplifying the inside consists of me combining these 2 x variable groups that I have in the numerator and the denominator into a single one, and doing the same thing for the y's there. And so let's go apply that rule there. First, I'm just going to rewrite this. And I think I'm ready to simplify this x group. There's an x in the numerator and an x in the denominator. And what do I know when I'm trying to simplify something over itself when I have the same base? Well, property 4 says I can subtract their powers. So whatever the power in the numerator is and whatever the power in the denominator is, I can subtract the two and get a single base with a single power now. We have to ask ourselves, of course, what are the powers in the numerator and the denominator? Up here, I see that my power is not written, but we know it's automatically the number 1, like there's an invisible 1 there. Down here, I see that my power is a 3, and so I know I'll be subtracting the numbers 1 and 3. I haven't changed anything else, so I'm going to leave it all the same for right now. I'm going to leave this the same. It just says 8y cubed. I haven't touched this 4, so I'm going to leave it as is. I'm still going to have my fraction because I know there's stuff going on in the denominator. But what's happening here? This x to the first power divided by x to the third power turns into x to the negative 2 power. And why is that so? Is because 1 minus 3 gives us a negative 2. And actually, maybe I can even write that out instead of skipping that step. Maybe we'll write that after. That turns into the 1 minus 3 power. I haven't touched the y's, and since I haven't done anything to it, it hasn't changed, so it stays the same. This negative 2 is still here. We're simplifying one step at a time. I see that I can do the exact same thing to the y's here. So I see I have y to the 5th power in the numerator and y to the first power in the numerator, and I want to use that exact same property 4 to subtract the powers in order to get a more simplified version of my y's. I haven't changed anything else, so I'm going to rewrite it. This 8y cubed is still there. That 4 is still there. This x to the power of 1 minus 3, of course, we can just write as to the power of negative 2. This y to the 5th power over y to the 1st power we now know as y to the 5 minus 1 power, which we could write as 4, but no reason to skip steps. One step at a time. Let's keep on simplifying because, like we said, 5 minus 1 is really just 4, so I can just change this into a 4. But what am I noticing? I'm noticing that inside of this group, I'm still trying to simplify the inside of this parenthesis group. I have a negative power, and we said part of simplifying involves not having negative powers. And so I need to get rid of that negative power. What property allows me to get rid of negative powers? Well, that's property 2. Remember, property 2 says when I have something to a negative power, I can take its reciprocal and poof, now the power is positive. And so I have x to the negative 2 power. Well, that's like having x to the negative m power. I know that it's equal to 1 over x to the positive m power, and so I know x to the negative 2 power is really just 1 over x to the positive 2 power, according to property 2. And so let's go and rewrite that. We'll also rewrite this 5 minus 1 as the number 4. And so I haven't changed this 8y cubed. It still is as is. I haven't touched this 4 yet. We know that the x to the negative 2 power is now equal to 1 over x to the positive 2 power. We know that y to the power of 5 minus 1 is now just y to the power of 4. And we still have all of that to the negative 2 power, which of course we need to get rid of. We don't like negative powers, but first things first, let's make this look a little prettier. I have my 8y cubed times I can write this as a fraction, with 4 in the numerator times 1 over, we also have a y to the 4th, that should be up there, but the only thing that's in the denominator is the x squared. Everything else wasn't dividing, and so it's in the numerator. All of that to the negative 2 power, and now I'm going to address that negative 2 there. I don't like negative powers. I know that I can fix a negative power or get rid of it by taking its reciprocal. What am I taking the reciprocal of? Well, that negative 2 power is attached to this group here, and so I'm going to take the reciprocal of that group. I'm not even touching this 8y to the cube to the 3rd power, and so I'm just going to rewrite it 8y to the 3rd power, but I am going to flip this fraction here. Why am I doing that? Is so that I can now have a positive exponent. When I do that, everything that's in the numerator comes to the denominator, and everything that's in the denominator comes to the numerator, and we now have this here. And it's a little bit simpler. We're not done though. Why am I not done? It's because now, looking at the big picture, I see that I have a group of parentheses. I see that I have a group bound in parentheses all to to some power. And I notice, well, that looks like property 7 that we have right here, where I can, in a way, distribute this power to the numerator and to the denominator to get whatever the numerator was to my power divided by whatever the denominator was to my power. Let's apply that here. I'm still not changing this 8y to the third power, so I'm just going to leave it there. And what am I going to do is I'm going to apply that second power to whatever's in the numerator, which happens to be x squared, so I get x squared to the second power. I'm also going to apply that second power to whatever's in the denominator, which happens to be 4y to the fourth, and so I also have 4y to the fourth to the second power. It's getting a little simpler. What property are we going to need to kind of break this parenthesis group? Well, recall that we have this property here that says when I'm powering a power inside of a group, that I just multiply the powers. And recall that we have this property here that says when I'm powering multiple things multiplied inside of a group, that I can just individually shower the power. That being said, I'm going to rewrite this 8y cubed because it hasn't changed yet. It's just stayed the same. And this here, x squared to the second power, well, I can use property 5 to declare that that's really just x squared times x to the power of 2 times 2. And that's over 4 to the second power times y to the fourth power to the second power, which is really just y to the fourth power times 2, using the same property that we see applied to the x in the numerator, where we get to multiply the powers. And so we're getting a little bit simpler, but there's still a little bit more to go. Of course, this 8y cubed has not changed. In the numerator, I see that I have x to the 2 times 4 power, which is of course x to the, 2 times 2 power, which is of course just x to the fourth power. In the denominator, I see I have this 16 because 4 squared is just 16. And I have y to the 8th power. It's a little simpler now. I think we're ready to address this 8y to the third power now. Let's put it up in my numerator because we know how to multiply fractions straight across. So 8y cubed times x to the fourth power over 16y to the 8th power. Now we just need to simplify these individually. Of course, the 8 can simplify with the 16 because that's just 1/2. That's just 1 over 2. We know how to simplify fractions. And my y to the third power can simplify with my y to the 8th power using that property that allows me to subtract the power from the bottom, subtract the power on the bottom from the power to the top. And this will finally simplify into 1 over 2 because of our coefficients. Y to the negative 5th power because 3 minus 8 times x to the 4th power. But we know we're not done until we get that negative power out of the power by bringing it to the denominator. And here we have it. We have x to the 4th is all that remaining because that 1 doesn't do anything. And the y to the 5th comes to the denominator with that too. And there's our final answer. It's kind of interesting to think that the original problem that we started with is really just equal to x to the 4th over 2y to the 5th power, considering how many steps it took us to get there. And the more comfortable we get with using and practicing our properties of exponents, the less steps we have. We can compact a lot of these steps into just little shortcuts and such that we didn't necessarily have to take, but we did take. Regardless, I hope this video cleared some things up for you, and I'll see you next time.